Hi, everyone. So today we're going to talk a little bit about the increasing and decreasing in first derivative test, which is the tab, like the 5.2 graphical applications, increasing and decreasing first derivative test tab. And currently we are above the fold and it is split in half. So the first thing we're going to talk about is the concept of increasing and decreasing. And this concept is going to tie back to when we talked about whether or not the particle motion, whether or not a particle was moving to the right or to the left, or whether or not it was moving up or down. Okay, so the same idea. So what does increasing and decreasing tell me? So as the x values get larger, the f of x values or the y values also get larger, is increasing. This is the definition of increasing. Okay. And then as the x values get larger, the f of x values get smaller, is the definition of decreasing. So that's what's happening on the graph. Let's talk about what that looks like visually. And these are all things that we've seen over and over and over again, especially in pre-cal before we got here, but kind of a nice reminder as to what we're talking about. So if we draw ourselves two really quick graphs here. Okay, so we have graph 1 and graph 2. And we'll talk a little bit about all the different things that can happen here. So I'm going to sketch in graph number 1. And in graph number 1, we're going to talk a little bit about derivatives, right? So when the derivative is positive, it's another way to think about this is increasing as the x values are getting larger, the y values are getting larger. That also means that the first derivative is positive. Where the derivative is 0, we say it's changing directions. In this situation, it's going from decreasing to increasing. And where the derivative is negative, it means that it was decreasing, okay? The other kind of graph that we can look at looks very similar in many ways, except for that it has a sharp turn instead. So that sharp turn is where my derivative is undefined, okay? Where the derivative is undefined. And we talked about the fact that it's a critical value in this situation because it's a sharp turn, but it doesn't necessarily mean that it's changing increasing to decreasing, but it does have to be tested for. We have another case of derivative is 0 here. We have another case of derivative is decreasing, or the function is decreasing because the derivative is negative. And another case of the derivative is positive, so the function is increasing. Essentially, all the things I just said are what make up that particular statement. So there are 3 parts to this. So when the derivative is positive, which means that f prime of x is greater than 0. The derivative is positive when the function is increasing. The derivative is negative when the function is decreasing. And probably the most important aspect here is that when the derivative is 0, it may change directions. Okay, all of this is stuff that we saw with particle motion. Okay. Today we're going to do an example of finding. We're going to talk about what the first derivative test is, and then we're going to talk a little bit about, tomorrow we'll talk about examples and what it looks like graphically. So let's talk about what the first derivative test says to start with, okay? So the first derivative test states that if f of x is continuous, what does that mean? Right, it means no breaks, no gaps, no jumps, no asymptotes, and no holes. And differentiable, what does that mean? Good, means you can take the derivative. It has two parts. So when the derivative changes signs, changes from negative to positive, or positive to negative, I guess we'll start with negative, positive to negative, changes from positive to negative, the function has a relative maximum. And remember, another word for relative is local. Number 2, when the derivative changes from negative to positive, the function has a relative minimum. Okay. So what we do is we look at it graphically. So we're going to look at it graphically, and then we're going to look at an example. Tomorrow, we'll fill in the example, but today we will take a quick look at a graphical situation, and then we create a number line. So we'll create our number line. So we're going to draw in a picture, and we're going to point out a couple of different places on this picture, okay? So the first thing I'm going to draw your attention to are places where the derivative is 0, and we're going to call those B and D. So they're where if I took the derivative and set it equal to 0, what I would get, okay? And those go on my number line, B and D, okay? Those are what we consider to be critical values. Now we also want to take a look at a couple of other points. So we want to look at a point that we're going to call A, a point that we're going to call C, and a point that we're going to call E. Those are the values that we want to test on our interval, okay? So in our situation, the derivative would be positive at A because it is going up. So this is A, C, and E. It would be negative because the graph is going down at C, and it would be positive again at E, because it's going up, it's increasing. So remember that B and D are my critical numbers. And what the first derivative test tells me is that because at B it changes from increasing to decreasing, we have a relative maximum. And at D, because it changes from decreasing to increasing or negative to positive, we have a relative minimum. What the Y value is of that particular relative maximum is not a conversation for today, okay? And the only way to get that Y value would be to have the function and to be able to plug it back in. So make sure when you're doing your homework that you're being very careful. Most likely it's asking for the X coordinate and not the actual value, which kind of gets kids a little bit tripped up. I'll see you tomorrow.